So, I think you can probably notice if you watched a few podcasts that I keep changing my glasses. This is just to make it more interesting, but I have friends like Harish and Vineet who think it's not a smart idea to wear such bizarre frames, but other friends like KK and Sanjoy think it's cool. Anyway, so that's just a comedy break. Nonetheless, it's good to understand that we are using these words climate change and global warming somewhat interchangeably. Many people prefer climate change because global warming creates little too much unnecessary debate. Nonetheless, if you want to understand the history of it, we can go as far back as 1820s when Fourier was the first one to describe atmosphere's contribution to planetary temperature. So essentially understand greenhouse effect, right? Before that, it wasn't completely understood, explicitly understood. There may have been cultural knowledge and so on, but that's not recorded. So instrumental temperature record begins around 1850, and Tyndall then was the first one to say carbon dioxide. Remember, this is already into the Industrial Revolution, coal burning, places where coal ash is being piled up, and so on. There is lots of interesting talk about how coal burning was already changing things, right? Acid rain and so on. So Tyndall, now there is a Tyndall Climate Center in the UK, big name, described the CO2 blocking of the infrared. So already the distinction between incoming solar and outgoing infrared or long wave was made. Then Arrhenius was the first one to actually explicitly try and estimate the warming that would come from doubling the CO2. So he was already worried that we are burning so much coal for industrial activities, by then already transportation, trains and so on, that atmosphere would considerably warm. So Arrhenius is kind of the first one to raise a flag about warming that could be expected from increasing CO2 too much, right? The rate of lunar heat loss was estimated somewhere in the 1920s. Hurlburt was the first one to calculate that doubling of CO2 along with the water vapor feedback would produce a warming of up to 4 degrees centigrade, even though it was a simple calculation at the time, without having big climate models, without having the global data, without having the Keeling's curve and all those things. It's remarkably close to what we still estimate, right? Further details, we know the uncertainties better now than at that time. So we are now more certain about the uncertainties of our calculation. But nonetheless, Angstrom actually refuted the calculations by Hurlburt. So you can see that even going back to the 1940s, already the debate about CO2 warming, CO2 forced warming was starting, right? So Guy Callender in 1937 wrote a phenomenal paper with very detailed calculations that warming was already happening. He used existing data and of temperature and carbon dioxide to show that actually warming could be detected. That's pretty amazing before global warming became big scientific endeavor, big debate for governments, big debate for international negotiations, and so on. Okay, and Roger Revelle and Suess were already discovering that the CO2 sources and sinks were there, and they were having Earth system feedbacks, and climate was responding to these feedback and so on. And you remember Roger Revelle was the one that asked his graduate student Charles David Keeling to start the CO2 measurements, which have now really served us so well in terms of pinning down the causes of global warming or climate change that we have observed in the last few decades. There is something called the Suess effect. there is a Revel factor. These all relate to the buffering effect of carbon cycle in the ocean. Remember that pH in the ocean is buffered because CO2 and H2O combine, form carbonic acid, splits into HCO3 minus H plus, and then splits into CO3 minus minus and H plus. That buffering is all by these guys. Okay, there is plus. Water vapor feedback was described. There's Jules Charney was asked to lead a study. Before that, Manabe and Weatherald. So Tsuki Manabe, who was at Princeton at the geophysical fluid dynamics lab in Princeton, was among the first ones to build an atmosphere model, and then Kirk Bryan built an ocean model. Then they coupled it, and Tsuki Manabe was the first one to do some model experiments to show that global warming was entirely happening and how the feedbacks would work. The Charney report was the first global warming report that actually mentions numbers of how much warming to expect, and it has again very simple calculations at the time, but it has served us well. It has turned out to be very accurate. Okay. Then Wally Broecker was the first one to look at the Keeling data and announce in the late 1970s that we were having global warming. Wally Broecker is a phenomenally well-known geochemist who died recently, I think early this year. Spent all his life at Lamont Doherty Earth Observatory in Columbia University, and Jim Hansen, who was working at NASA in Goddard Institute of Space Studies, also located within Columbia University, testified to the Congress in the 1980s that global warming was here. Before that, there are a couple of other papers by Ramanathan, which also had shown that global warming was happening. Satellite observations have since confirmed the greenhouse effect very clearly and the impacts, and you can see above here the instrumental records, CO2 measurements, clearly recording the almost monotonic increase in CO2. It turns out that there is some relation between our emissions and our economic activity. So when you have things like a recession, financial problems that slow down human activities, or COVID lockdowns which reduce travel and traffic and manufacturing and so on, you can see a little bit of flattening or reduction in CO2 emissions or emission rates, but things get back very quickly to normal as soon as economic activities pick up. And now the impact of COVID lockdowns is completely washed out. Everywhere it's pretty much back to normal. Okay, so that's kind of a very brief run through the historic steps which have led to the current level of awareness, process understanding and predictive understanding of CO2 feedbacks and other greenhouse effects feedbacks within the system. Feedback. This is very important, and I'll explain how they are computed and how they are identified and so on. But feedbacks are the most critical thing in the climate system, in the Earth system. You do one thing, 10 other things change.